piece and how it's answered. The subsequent questions should be easier. For each pair of graphs shown, determine whether g of x appears to be a right-hand behavior model for f of x, a left-hand one, or neither. So when we're talking about the models, what we're saying is, does the g of x do the same thing going to the left positive, or left infinity, right infinity, as the original f of x? So as I look at this function, does the g of x model or do the same thing as I go out to the right or positive infinity as the f of x? Looking at what's there, Davey, what do you say? Okay, so the g of x models the left end behavior. And now let's look at the right. So look at the g of x, look at the f of x. Does it model the same behavior going out to positive infinity, Catherine? Okay, so this g of x is a left and a right end behavior model for the f of x. Let's take a look now at 2. Knowing what you know, what would you give as your answer for 2? Hands up, please, when you can give that out. Look at the g of x. Does it model what's happening as we go to the left and to the right, or positive and negative infinity of the f of x? What would you say, Evan? What's that? No? As this g of x goes out and trends out, it's going to some positive value. What is the original function doing? Okay. What happens is the g of x goes out to the left? It's going to a negative value. What's it doing here? So does it model? What would we say for 3? Looking at what's there for 3. Hannah, 2, what do you say? It's just going to be the right. How about for 4? Megan, what do you say?
The left.
Terrific. Questions on that? Let's bounce over to the next page. For 5, we need to go through and make sure that we identify whether the function is represented is continuous at C. If it is discontinuous, identify the type. So looking at what's there, for A, is it continuous at C? Cameron, what do you say? So this is continuous at C. Steve, what would you say for B? Is it continuous? Well, let's say continuous. Steve, what would you say for B? What type of discontinuity does it have? How about for C, Molly? Not continuous, yeah. Now, what type of discontinuity do we have? There's, I guess, more than one way. What do you want to say? What's that? Yeah, it's got discontinuity at a point. This is what we'll call a removable discontinuity. If there wasn't a value there, it's possible to redefine this such that that point plugs that in. How about for D? Is that continuous? Abby, what do you say? So we say it's discontinuous or not continuous. What type of discontinuity do you have? More than that. Yeah. Does anybody know what this type is called? Yeah, this is a jump. Now, how about for B? Hannah 1, is that continuous or discontinuous? What type of discontinuity do you have? How about for F, Sierra? And what type? Terrific. Terrific. Give an example of a function now that's going to have these types. Now, for all of you, this is going to be a little bit different. I have my examples down. Josh, give me an example of a function that has only one point of discontinuity.
Okay.
No, I'm giving an equation of one.
Oh, equation.
Mm-hmm. Who can give me an equation that's going to have one point of discontinuity?
I said it's squared divided over x.
Does anybody have a different one? Exactly 2 points of discontinuity. What's that going to look like?
I said x plus 18 over absolute value of x minus 1.
You said x plus
18 over absolute value of x minus 1. No, and over the absolute value of x.
So what values would cause that then to be discontinuous?
1 and negative 1.
Okay? I've never even seen a function like that before. Let's see if, can you graph it for me? Go with your calculators now, click and graph it. Make sure you signed in. I'm just saying, it's not because I'm saying, you know, it's something impossible to do by any means, or that he's wrong. I've just never seen, I didn't view it that way. Because we don't teach it to you that way in pre-calc. But it looks like we are going to be discontinuous at two different values. This, he gave it as the, so control division, x plus 18 in the numerator, and then the denominator, the absolute value of x minus 1. Boy, I bet that's got an interesting graph. Let's see. Who's got it in there? Let's do this, make presenter. Now, as much as I hate this, go in, please, and do, try to go to menu. Window for 4. Let's see if one of these Zoom stupids will work. Do Zoom fit. Try A. And let's see if this will make it. Yeah. Perfect. He's absolutely right. Where is it discontinuous at? -1 and 1. That's perfect. And again, you have to understand, there's so much thinking that's involved in this. Somewhat, I've been doing this 13 years now. We just had something I'd never even encountered before in my life. It's absolutely right. Take a look at, does anybody have a different one that they wanted to use that has 2 points of discontinuity? No one else was able to give a second? What do you want to say?
1 over x minus 1 x plus 1.
Okay. Y is equal to 1 over x times the quantity x plus 1. Sure. Where is it discontinuous at?
At 0 and negative 1.
How about something that has an infinite number of discontinuity points?
Oh, I know. 1 over x squared.
No. That's because that would only have one at 0. Think about it. It would have to be something that sort of has a repeating vertical asymptote. Yeah.
Y equals
No. Go with your calculators and see. That's going to be the graph of the square root function. I mean, I guess if you're saying, well, no, because it's not discontinuous at negative x's. It doesn't even exist there. I saw it a little bit differently.
Y equals tangent of x.
Yeah. If I were to go through and graph out any of our reciprocal functions or tangent, because remember, tangent is defined in like 180 degrees or 90 degrees, or sorry, 180 degrees or pi radian intervals. So it's discontinuous at pi over 2 and every pi after. Now, give an example of a function that's continuous everywhere. Adam, what would you say is a function that's continuous everywhere? There you go. Now, this was one, play around with it, and this is a number theory question. For every number that you pick, no matter what the number is, let's say it's 1 and 2, you can always find an irrational number between those two values. So think about that. 1 and 2, what square root would fall? Think about the decimal equivalent. What square root would fall between the square root of 1 and the square root of 2?
Square root of 3.
Square root of 3, what's the square root of 3 about, you remember? Go in and type that in your calculator right now. Type that in, control, by the way, I think if you do square root of 3 and hit enter, or put a dot after it, it may show up. What's it come out to be, 1.7 and some change, is that right? Yeah, okay. So, now I go through and say this. There exists a square root that you can take between 1 and 1.1 that will fall in between it. There's an irrational number that falls between it. So the rule is this. You can always fit one in between any two values that you pick. Here's one that I came up with when I was trying to figure out what's one that maybe makes sense for you. I'm going to give it out as a piecewise function. So f of x is equal to two options. We've got 0 if x equals a rational number, and 1 if x is equal to an irrational number. What's that going to cause to happen constantly? Perfect. I'm oscillating between 0 and 1 at every possible value. Because no matter what two, I could pick 1 and 1.1. I could pick 99 and 100. I can pick 99 and 99.000001. Something resides between those two that's going to be an irrational. Something I take the square root of, let's say, 46 and divide it by 11, or whatever these numbers are. It's possible to find something that makes that happen. Now, that's your warm-up. Please have your notes out, open to day 9 stuff. And again, make sure that you now, yeah, and we'll remind me again, we'll fill out the front, because just so you know, you all have a quiz next class. It's on your sheet as well. Now, and I have your quizzes from before, and you'll get those back. I have to hang on to them, and just so you know, I can, let's say it this way. I'll say it to you politely now. Well, I'm not going to let quizzes leave the room either. We're going to, at some point, maybe even today if we have the time, you're going to get a manila folder and put your name on it. Every test and quiz that you give is going to be left in this room. Reason being, you all are going to be a day or two ahead of Miss Miller's group. And for two reasons. Number one, academic dishonesty is, and if it is up to me, I will actually take it to Mr. Benz and ask for you to be removed from the course. Because it is so antithetical to the spirit of what we do to just be copying from somebody. It's offensive. It's not a life success thing at all. Again, if you are going to fail, fail spectacularly and fail on your terms. It's better to fail alone than it is to pass. And for some of you, I made this very clear. I got messages from previous students that weren't successful in this class, but took calculus when they were in college and it made a lot more sense. And they're 98s, 99s. I even got a message from another one the other day going, calculus is so easy because of the work that we did even in pre-calc. So make sure that you're not cheating and sharing with other people, period. That's a big one. And just so you know, whenever we have tests, something that's going to happen, you're going to leave all of your phones up here. The other thing is, because I found out some people were doing this last year. No potty breaks while you're taking. So if you need to go, you can go beforehand. If it happens and it's an emergency, We have a tree. I don't know if you've taken AP biology. It's a terrific way to process in an environmental way any form of biological waste that we have. It may take a while, and it certainly would be awkward for all of us. There's also a window if you don't want the smell to be in the room. The other end of it is a lot of the questions that you will be taking are AP level questions and are asked from a previous exam, so they're what we call secure. They're not allowed to be released. So you will be, that's why you leave at least most of, that's why all the tests are left in here. I'm going to ask quizzes for the same reason, just to, so you all are not aiding and abetting someone in another section. And don't discuss it with them either. Why would you want them? That's the other thing. When Miss Miller and I get together and I go, God, my kids are doing terrible on it, and your kids are doing wonderful. I wonder what it could be. Well, if one of those variables is you going off and telling them, that makes you look bad. And if they're asking you, lie. Don't tell them the truth. Be like, oh my God, it's the strangest thing. It was all on factors. I know it said it was on continuity. We just went with factors. It was all quiz on factors. It was a difference of perfect squares. 40 times. And then we handed it in. I did terrific on it. That's what I decided. Lie to them. They're jerks for asking you and putting you in an awkward position. It's like if somebody goes off and commits a murder, they go, hey, can you hold this bloody knife for me for a minute? Or can you get rid of this knife for me? That'd be really helpful. What kind of friend does that? And what kind of moron helps them? Now, the stuff that we're going through and doing today, it's a very interesting concept. I'm going to ask you this. I'm going to say this. You know how far away, let's say this, the distance from Rochester to Syracuse, actually we'll do Buffalo, so we'll make this geographically, we're North American Central. This would be Buffalo. This will be Rochester, and I'm going to say that this distance from here to here is 60 miles. Now, you're driving in Buffalo, and I clock your speed. There's a state trooper sitting here at Buffalo, and he catches you. Have you ever driven above the speed limit? Catherine, right now, is going 55 miles an hour on the thruway. That is 10 under because she is cautious. You know from your work with calculus, you approach limits, you don't exceed them. Then, and this, Catherine, happened at 8 a.m. Now, we clocked Catherine again in Rochester at 9 a.m. going 55. And she gets pulled over. She's going to get a ticket. Does anybody know why? There's legal justification for her to get a ticket right now. And if you think this isn't how things happen, down in Florida, this is exactly what they do. They have their easy pass are things that you drive underneath. What do you want to say? How far did you travel in 1 hour? 60 miles per hour. She never, we're going to say, her trek from Rochester to Buffalo is continuous, meaning she didn't ever get off it. Here's my speed. If right here she's going 55, and here she's going 55, but she covered this amount, at some point on there, it is indisputable fact that she had to be speeding, even though it wasn't measured. Why? Because if your graph is continuous, and you know the endpoints, you have to take on the value in between at some point. We'll go into examples of what this looks like. If I have a graph, I start off at, let's say, 2, and end at 9, and I tell you that this is continuous from point A to point B, who can tell me a value that this function is guaranteed to take on at some point between A and B? This is not a question of where, but what values is this function guaranteed to take on? And I'll say this, hidden behind this magic door here is some continuous function. What value do you know? What value are you guaranteed that that function hits if it's continuous from A to B? What's an output value you're guaranteed to hit? Yeah. Any value between 2 and 9. So give me one. 5. What else? Who can give me another one? 7. Now, are you guaranteed to hit 1? Is it impossible to hit 1? No. You could draw a function that's continuous from A to B that hits that. That's called your intermediate value theorem. So these values here, you're guaranteed to go through and hit. Could you hit anything below it? Yes, but it's not guaranteed. It's impossible for me to draw a continuous function from A to B without hitting that value. Does that make sense? Because that's a calculus concept. Now, we're going to go over, here's our notes for today. We left off on page 18. A theorem has both a hypothesis and a conclusion. Whatever. This isn't AP literature. I love, just remember all those little catches you get from me, just wait until I get a hold of your first text. Oh, does that say limit as x approaches 6 or 5? Wrong! You spelled it, how is it wrong? Hilarious. Theorem is a hypothesis and a conclusion. When the hypothesis is met, the conclusion must be met. If a shape is a square, then it's a rectangle. So if you know the start, you're guaranteed the second part. For each of the following statements, let's do, if a shape is not a square, then it is a rectangle. Can we, for each of the following statements, give an example that satisfies the statement, or explain why it is not possible to do so? So, if a shape is not a square, then it is a rectangle. Who can give me, is that true or false? Who can give me a counter example then? What do you want to say? There you go. If a shape is not a square, then it's not a rectangle. Is that true or false? If a shape is not a square, then it is not a rectangle. What's the counter example? If a shape is a square, then it's not a rectangle. Is that true or false? If a shape is a square, then it is not a rectangle. If you're going to say false, what's your counter example? Careful. Is a square a rectangle?
Yes.
Does a square meet the criteria of a rectangle? Are opposite sides parallel? You bet. So if it is a square, then it is not a rectangle. So that's false. Now, our last thing that we're going to go through and do is this. Here's the gist of what we're hoping that you get. The intermediate value theorem states that if a function is continuous on, the closed interval from A to B. And M is a number between f of A and f of B. That means the end output values or the y values. So if x falls between there, and you know the endpoints, and you know the x's that it ends at, and you know the y values that it ends at, there exists one number in C such that it takes on M, which is somewhere between them, between those output values. So what you're saying is that if I have known n values, I know where it ends, and I know where it starts, and the function is continuous, I know it has to take on every output value or function value or y value between the lowest and the highest. It has to encounter all of them from the start to the finish. We use this to show and guarantee the existence of zeros. So if a function is continuous and one output value is negative and a later output value is positive, what has to happen somewhere between there to the output value? It has to equal 0 or to give you an x-intercept. If the ends are not the same sign, you have to hit 0 to go from a negative to a positive and vice versa. Now we're going to use it to prove this out. Does this function have a root on the closed interval from 3 to 4? A root is the same as an x-intercept. How can we show that? I'm not asking you to solve it out. I'm asking, does one exist? Let's evaluate the function at 3. Go through right now, please. Don't go to the calculator. Tell me what the function value at 3 is and the function value at 4. So go through right now. Don't go to the calculator, because again, if we're that dependent on it, it's going to be rough on that AP exam. Sam, let us know what you get for the function at 3. And Leah, when you get it, let us know what you get for the function at 4. When you get them. You got negative 16, that's absolutely correct. No. I've got a value for f of 4. None of you did? 1, 2. I know. Instead you go through withdrawal. It's a lot like, there's actually an episode of Intervention that we filmed it here before when we took the calculators away from it. It's a lot like intense drug withdrawal. John! What did you get? 67. Something different. What? 13. What's 4? What's 4 to the third power? 4 times 4 is? 16. Times 3 is? Or sorry, times 4 again is 64. Double that. 64 times 2. Honey, if you can't take $64 and double it, I hate to see what kind of industry you end up in. Yeah, so we got 128 minus 5 times 60. You can do the math. Like it.
16 times 5.
Let's say I get stuck, right? Ready? Oh, 16 times 5. Well, this is 5 times 6. 5 times 6, that's 0, carry the 3, that's 80. Okay. Minus 40 plus, come on. You're right. It's too much.
What colleges are you applying to?
Let me call them up. Now, does this have a root in here? Yes or no? Does this have an x-intercept? It should. You just verified that one happened because the function at 3 is negative, the function at 4 is positive. This is where you're going to lose points because this explanation matters. You need to state that the given function, f of x, is continuous. And it's got to be continuous. Well, we'll show you the definition. You need to state that it is continuous and that something happened with the function values, that your value resides between f of 3 and f of 4. The sentence that you're going to state is as follows. Since the function is continuous over the closed interval, there must be a root equal to 0 over that interval because the function value at 3 is less than or equal to 0, which is less than or equal to the function value at 4. Now, there's more than one way of giving this, but this is where people stumble. And we talk about notation can actually make the difference between a kid getting a 5 and a kid getting a 3. They know the exact same amount, but if you're too lazy to give out an adult sentence stating you have, before you can use, and we'll get into it later, you have to state some conditions before you can use the intermediate value theorem. The function needs to be continuous over the given interval for you to use the intermediate value theorem. Now, is this definition tight enough? This doesn't say use the intermediate value theorem. We're just probing. This is our first step in. AP answers would say, since the function is continuous over the closed interval from 3 to 4, and the function is continuous, by the intermediate value theorem, we know that this happens since the endpoint values are such and our value is sandwiched between them. There's a lot you have to say to use the intermediate value theorem. Being short with your language is not going to help. We're going to do some refresher questions. Take a look at this first one up. And again, these are actual questions, so stop thinking that this is, something where I'm being difficult on it. And these are the easy of the three responses. The first one up is from 2003's released exam. Let f be the function defined by that definition. Is the function continuous at 3? Explain why or why not. So, Sam, in order to show the fact that it's continuous, what do I need to remember? What do you know about those three things? To show that it's continuous, we need to show the limit from the left equals the limit from the right equals the function value. So, let's bang some of these out. Which one do we want to go through and do first? Leah, do you want to do the limit from the left at 3, the limit from the right at 3, or the function value at 3? Okay? So as we approach 3 from the negative side, which piece would you be using? And I can make that and evaluate it out by direct substitution. What is the limit from the left going to be? Jack, what do you say? Now let's do the limit from the right. And Jake, if I'm evaluating out the limit from the right, what piece am I going to be using? So what is the value of the limit from the right going to then be? This is what you need to show. Now the last thing I need to show is the function value at 3. So Mike, which piece am I going to be using if I'm evaluating out the function at 3? Top piece or the bottom?
Top.
Okay, and what's the function value at 3 going to be?
2.
What did we just show? Give a summary sentence. Again, you act like we're above that sometimes. You're not. You need to state what you did. They want to see that. That's harder. When it says justify your answer or explain why, That's exactly what we're looking for. The left-hand limit equals the right-hand limit equals a function value at 3. And that's a review question. Now, this next piece is going to be one, we actually, I think, reference this question multiple times during the year. This is a terrific AP question because they give you stuff right now that you really don't know how to do, and if you get on weak footing, you fall apart. 2007, 3A. The functions f and g are differentiable, which means you can take the derivative, which means it's continuous. Are differentiable for all real numbers, and it's strictly increasing. G is strictly increasing. The table above shows the values of the function and their derivatives at select values of x. The function h of x is defined as f of g of x, then minus 6. Explain why there must be a value r in between 1 and 3 such that h of r is equal to 5. If you're proving the existence of a value between two end values, that is referencing the intermediate value theorem. You need to determine the values at the end and then see whether or not yours, if it's continuous, it's got to hit it. Now, let's evaluate out h of 1. How could I go about evaluating h of 1? You tell me. Just sit and stare at it. How is h of 1 defined? I have 2 people. We can do better than that. 3 of you. Read the question. How is h of 1 going to be defined? Or what do I need to do? Jason, would you give a try to evaluate out h of 1? Yep, and we're going to start off and I'm going to take g of 1. So, looking at that, Jason, what's g of 1's value? 2. So now I need to go through, and we said g of 1 is 2. So now I need to take f of 2 minus 6. Kanji, what's f of 2's value going to be? Okay, and then what do you have to do to that value? Subtract 6. So what's h of 1's value going to be? We get out of 3. All right. I hate when people use their real pictures too. It's very. Does everybody know what my picture was in Google Classroom? Anyone knows? Go check it out today. What? Yeah. Who here's watched the Golden Girls before? None of you? You just wait. Maybe before Christmas we will watch the episode together. Now, we need to evaluate. We'll do it actually after we get through. We'll take it back. Now, take a look at h of 3. How would I evaluate out h of 3? Noah, what would you have to do? Okay, so I need to evaluate out g of 3. What's g of 3's value, Noah? 4. And then I need to evaluate out f of 4. And what's f of 4's value, Davey?
-1.
-1 minus 6 is going to give you what? Is there a value between 1 and 3 that would give us, so such that when you take h of that value, you get out a -5? How do you know? Now we need to say that using calculus, using proven theorems that we can access. First thing up is, the reason that you know that is the intermediate value theorem. Before I can state that I'm using the intermediate value theorem, what do I need to state about my function? It's continuous over the interval that we're looking. It doesn't need to be continuous forever. It just needs to be continuous over the interval that we're looking at. So I would go through and state this. And there's a lot of writing, and this is when people, again, shut down. Since h is continuous for all real numbers, we knew that from the directions, the stated fact in the beginning of the question. by the intermediate value theorem, there's some input r between 1 and 3 such that h of r equals -5 because we sandwiched it. We pinned it between it. That's what Noah was saying. He said, I know it's this value below and this value, or this value to start and this value at the end, and my value falls between those two. I know that. By the way, you also showed that there's an h of r that will equal what other values? Hands up, please. You can tell me. Does h of r has to take on what other values between 1 and 3? Give me another value that you're guaranteed that this will take on. 2 people? Are you kidding me? You could say it takes on 2. What's another value it's got to take on? 1. What's a value you are not guaranteed that it takes on? 5. -9. -8. Questions on there? That's the sentence you need to give out. You need to state that it's continuous. Being continuous unlocks the intermediate value theorem. And then once you've stated it's continuous, so the intermediate value theorem applies, then the properties of the intermediate value theorem apply because I'm sandwiching it between those values. That's what that sentence is telling you. And the sentence you give is pretty much the same every single time. Questions on this? It's a tough question. Next one up. All right, a car travels on a straight track. During the time interval from 0 to 60 seconds, the car's velocity, measured in feet per acceleration, or feet per second and acceleration, are continuous functions. This is important. When you see that they're continuous functions, what door does that open up to you? Intermediate value theorem. The table below shows these. Between time 0 and 60, that there must be a time when the velocity equals -5. Justify your answer. Who can answer that? You stare at me. Let's do this. Let's do this. We'll give you... go through and answer right now on your own. Go through and answer it right now on your own. If you need to reference a previous question, go ahead. But I'll give you a couple minutes. Go through and answer it right now on your own. And then you'll see, I'll show you my definition. You give a big kid sentence. You state what needs to be stated to unlock the intermediate value theorem. You state the interval that you're working over. You state how you know this is going to happen. Remember, the intermediate value theorem, and you have to meet certain conditions. It's a very difficult thing to wrap your head around how much explaining you need to do. Calculus is not about plug and chug, it's about analyzing situations, big complicated problems. And you're getting, really we're saying, if you look at the inputs, my value falls between them. Right now? Probably not if they have that much free time. I'm going to say this. The value no,
B of 0.
B of 0. Reference to details are your friend. Remember, details are our friend. You give the justification. Be specific. If I would go, think of it this way. Don't answer it at your terrible level. Answer it at my terrific level. What would Matt give as an answer? What would he say? Molly, what's your sentence going to look like? What do you need to say happens first?
Well, first you say then velocity is continuous for all real numbers, then by the IVT there must exist.
Okay, so she's gotten to that point so far, and you're not far from being right. I mean, you got the setup initially. I said this. Now, maybe we can say it even more succinctly. So let me do this, actually. So, Molly, read me what you had down. Hang on. Since V of t is... Okay. I'm going to say this. I'll say this part in the beginning because I like to throw this in the beginning. Miss Miller throws it in the beginning. We know it's continuous. And now is when I state what my end values are. Now you're trying to guarantee that we hit, what was it, -5? So there's a bunch of answers for this, by the way. What window do I want to look at, or between what values am I guaranteed that that -5 is going to be hit if it's continuous? V of 0, or sorry, V of, not V of 0, V of what? 35 and 50, or whatever it ends up being. Okay, so, and we know V of 35 equals -10, and V of, what's the other one, 50? Equals 0. Then by the, now, and this is another one, and I'll have to check. I'm not trying to be a wordsmith or be more of a jerk than I already am to you. I believe you can use IVT on the exam. I'm not 100%. Remind me, please, to ask. I don't know. By the way, did everybody get that message that I sent out to you with the discussion question about whether or not? Those are the discussions. Understand, we're in the same boat as you all are. So that was a terrific explanation of what was going on. Okay, then by the intermediate value theorem, what can we say to finish this off? What do you want to say to finish it off? Who can tell me? John?
There must be a time when
V of... Ah! Ooh! I know, I was an idiot. It shouldn't be V of 5, by the way. V of t equals 5, -5, since V of, what's our lower bound? V of 35, less than, now I don't know how to do the less than or equal to sign, so I'm going to do this, which is going to be less than -5, which is going to be less than V of 50. And because, I don't know, keyboards were not designed by people who like math, because they give stupid things like punctuation and then they'll give a greater than or less than. That's doing it in your words. We accomplished the exact same thing. We stated it was continuous. We unlocked using the intermediate value theorem. I did, right? Oh yeah, and we stated my value, my intermediate value to the north well. Now, this sheet right here is what your homework is. There's also a quiz next time that we have class. Go to the front sheet on there. Start filling in your days. What's today's date? Which the 20th. The 20th. We don't see each other, but we see each other Thursday, Friday. Is that right? So that means Thursday, Friday, and then when we come back, review and then test. You have a gap between the review day and the test day. Tough cookies. Tough pumpkin spice cookies. Ooh.